Hello people of YouTube, it's Deepak here, and welcome to DCS World 2.7.5 and Deca Ironworks Simulations JF-17 Thunder. Welcome to Tutorial 2, Takeoff, Navigation and Landing. After last time's video where I showed you how to start up the aircraft, the next thing for us to do is go over the basic navigational features of the aircraft and take it up for a flight. Today we're going to be covering the symbology that you're going to see on the HUD, the HSD, which is your primary navigational aid. We're going to do some navigation, we're going to take off, and we're going to land again. So, a nice video covering all the basics of operating the aircraft. Very first thing we're going to do is we're going to focus down on the HUD here so that we can see all of the symbology that we've got. And I've got to say it's a rather busy HUD. If you thought the F-18 had a lot of information on its HUD, this is even more so, or at least even busier looking. Let's take it in columns. Let's take a left-hand side column here. We've got angle of attack in units. We've got G. We've got our airspeed here with a tape, currently displaying C for calibrated. It's possible using the UFC to switch it to true. We have our Mach number. We have our current master arm condition, which is safe. We have our current master mode. Now it's important to note that you've got a switch on your HOTAS to go through the master modes. You can push that switch forwards for intercept, which is air-to-air basically, rearwards for air-to-ground, and you can pop it back into its center position for navigate. For the entirety of this mission we're going to be using the aircraft in nav master mode. You've got your maximum G for this flight. And then down the middle we have a standard kind of compass, heading tape across the top. We have our flight path marker, and currently the flight path marker also has the tadpole centered on it, which is what we use for navigating. It's very, very similar to the tadpole that you'll see in the F-16, where basically you put your flight path marker on the route of the tadpole and you're flying towards your currently selected waypoint. It also gives you this kind of angled offset to show you what direction it is currently in, and this line is actually the distance to the waypoint. It's a little bit of a strange representation, but as this line travels down the tadpole, you're getting closer to the waypoint. Down the right hand side we have our current altitude on the right here. We have the radar altimeter. We have the delta T, so like the difference in time between when you're going to arrive at the currently selected waypoint and when your time on target was programmed for. We don't currently have a time on target, so it just displays 0. We then have the current waypoint information. So we're in flight plan A. The aircraft actually has an A and a B flight plan. So flight plan A, steer point number 1, 12 nautical miles. And then we have just the clock, current time. The next thing for us to take a little look at is the HSD, which I've got down here on the right-hand multifunction display. Now, all of the multifunction displays are split, with the main window appearing at the top, and you've got a lower area here. If you hit return, you always have the ability to choose a different lower display, and these are Engine Primary Instruments 1 and 2, Stores Management System, which is currently turned off, and AFD, which is Airfield Data. When you select the HSD, it's default for the bottom half to be airfield data. This displays information on all your closest airfields, and it even gives you the steer point numbers. Now, it's worth talking about, well, waypoint numbers, I guess. It's worth talking about the waypoint numbers in this aircraft. Waypoint 00 is always your initial position, and that's if you're going to align the aircraft's INS. 00 is what it uses as the current position. Waypoints 01 to 29 are your normal waypoints used for navigation. 30 to 35 are what are called route points, and these are used for cruise missiles, basically. You can define a route using waypoints 30 to 35 that your cruise missiles will follow. 36 to 39 are target points used for GPS-guided weapons. 40 is always your current SPI, or sensor point of interest. 41 to 49 are mark points. We'll cover those in a separate video later. 50 to 58 are your nearest airfields, as we can see here, and we can actually go through these. 59 is automatically what's called your bingo airfield, which will always be the closest airfield. And I'll demonstrate the bingo functionality a little bit later in this video. If you want to know what these numbered airfields correspond to, you can open your kneeboard, and the airfield information is always written down in your kneeboard, complete with frequencies and Tacan and so on, which is very, very useful. So 00 is our starting location, which just happens to be an airfield as well. But Akrotiri, which is where we're taking off from, is airfield number 50, and we can see here that we're currently at airfield number 50. Also gives you bearing, altitude. Does this airfield have ILS? Does this airfield have Tacan? So that's pretty useful. So anyway, onto the HSD here. Currently selected waypoint has distance and bearing information at the top left. It's possible to turn on your Tacan information at the bottom right here, distance, bearing, and MCRS, course basically. We don't have a Tacan tuned yet, but we will before we take off, and I'll show you that. Map allows you to display the underlying map. I'll have it turned off for takeoff and landing, but I'll probably have that on during flight. True allows you to switch between magnetic and true headings, and then we can change the range scale here. Last button here controls what information is displayed from your radar warning receiver. We currently have the RWR off. The HSD in the JF-17 is really interesting because it's a combined display. So it displays the same information that, say, on an F-18 you would have on the EHSD, the situational awareness display, and the RWR. All of that information appears here. So like data link information, RWR information, navigational information, everything appears here. Again, probably makes it a little bit cluttered, but it is a very, very useful display. Okay, so the last thing we're going to do before we take off is we're going to program our Tacan. So let's go main menu, Tacan. Now, what to note is that you actually have presets for your Tacans. You can program up to 10 Tacan stations and quickly flip between them using these presets here. I'm just going to program up Tacan preset number 1. 107 is actually correct. It's actually preset for the current airfield. It is X-ray. We're going to switch the mode to air to ground, which is transmit and receive, pretty much on any other aircraft. We're going to edit the course line and set it to 288, which is the course for runway 28 here at Akrotiri, and I'm now going to bring the EFIS back up on this side. We now notice that we have the annoying sounds of the Tacan, so we're going to actually turn that down using this volume control here. Let's just imagine we've confirmed that Morse code is correct. And then back on the HSD, we're going to enable Tacan, and we now have Tacan information. We have the Tacan symbol for the station, we have the course line showing us the alignment of our runway, distance to the station, bearing, currently set course, and then we have the yellow triangle giving us the heading for that Tacan station. It's telling us that we would need to turn left. Okay, so let's get the aircraft ready for takeoff. So very first thing we're going to want to do down here is we're going to want to turn on the taxi light. We're going to want to disengage the parking brake, and we're then going to taxi to the active. It will make sure that nose wheel steering is on. You can confirm that with this eyebrow warning panel here. You want to tap your nose wheel steering button. So let's throttle up just a touch, get the aircraft moving. Make sure the brakes work. They do. Nose wheel steering also is working. So one thing to note, the fly-by-wire in this aircraft has a automatic pull-up feature. So at 100, or an automatic rotate, I guess you would call it, that occurs at 180 knots, which it's more of a fail-safe than something that you should actually rely on, in my opinion, because that's actually a bit high of a rotate speed for most loadouts. We have a moderately heavy loadout today, but we would probably aim to rotate at about 140 knots, I think, with full afterburner. So I'm not going to demonstrate the auto pull-up today, but just be aware that if you forget to rotate the aircraft, it will rotate itself, and it can actually do a perfectly good takeoff hands-off. So yeah, something to keep in mind. So we're just going to make our way to the active just now. Well, I just realised I don't have my engine instruments on the left here. Let's bring those up. I usually use the left-hand multifunction display to reference the engine instruments. Okay, we're going to take the centre line, and then we'll do a standard takeoff procedure. Now, when the aircraft has a light loadout, you don't need to use flaps. Today we're carrying 2 fuel bags, which does make us a little bit heavy. So for today's flight, I am going to enable the flaps. Now the flaps are manual. Well, the trailing edge flaps are manual. The leading edge flaps are automatic. So we're going to flip this switch into the down position and we get confirmation of TEF for trailing edge flaps. Something else to note, the engine has multiple modes: training, training in combat, and pure combat. This controls the maximum N2, so it basically controls the output of the engine. Today we're going to have it in training in combat mode, which is kind of the normal. If you are doing air-to-air combat, you're going to want this switch into combat. It unlocks the full capabilities of the engine. Other things to note is that you want the afterburner switch on, otherwise afterburner will not be available, and the anti-surge switch should basically always be on. Okay, just having a quick look at everything else, put the lights into flash, and we are ready for a takeoff. So, for takeoff, what we're going to do is we're going to spool the engines to 80%. Ensure that all of our readings look stable. For a light takeoff, we would set 90% throttle. Because we're a little bit heavier today, we're going to go full power. So nose wheel steering off. I'm going to apply full power. And like I said before, we're going to look to rotate at about 140 knots. (140), bit of backstick pressure. And we're airborne. Gear coming up. Flaps coming up. And we want to ensure that flaps and gear are up and locked before 300 knots. I'm going to come out of afterburner now. And there we go. Actually, I'm going to turn off Tacan, just to kind of declutter the display a little bit. And we're going to make our turn towards that first waypoint, making use of the tadpole. And I'm going to climb to 10,000 feet. Now you'll also notice that you have carets on the altitude and on the airspeed. And those are there to guide you towards the settings that you programmed for this flight plan. So for things like time on target or preset altitude and so on, those are going to help you achieve those values. You can see climb performance is pretty good. Well, I've been flying the Harrier a lot recently, so most aircraft's climb performance feels really good to me. Gonna set the throttle back to about 90% now and reduce our rate of climb. That should be plenty. Okay, rolling off on heading now. And we're coming up on altitude. And you'll see that we have a little square. That's our currently selected waypoint. And it hangs in the air at about the right altitude that you've set for that particular waypoint, which is nice. Okay, so we're inbound waypoint 1. While we're inbound to waypoint 1, I'm going to demonstrate another couple of features used for navigation. This here is your waypoint update mode. Manual means that we manually need to change waypoint, but if I hit this, we can change it to auto. And it will then automatically cycle waypoints once we get within 2 nautical miles of each waypoint. Next thing I'm going to demonstrate is the autopilot. I'm going to press AP. That automatically puts us in attitude hold mode, but if I press here, I can enable altitude hold mode. The aircraft will hold a bearing that it was currently on unless the roll was more than 7 degrees when you engaged it, and it will also hold the current altitude, although we have the option to change that. And if we change that, let's say that we put it to 11,000, the aircraft will automatically climb or descend to achieve that preset altitude. So you can see here that I'm doing an automated climb, which is a pretty nice feature. Okay, we're about 2 miles, and there you go. Straight away, you see it's auto-switched to waypoint 2. So, I'm going to roll the aircraft over, and the autopilot can be maintained on in that mode, but what you're going to find is it's going to fight you up until a point, and then it's going to disengage automatically. So just so you're aware, you can disengage the autopilot just by yanking on the stick. Alternatively, you could click the AP button again, and it would disengage. So we're now inbound waypoint 2. There's the square. And we just line up the tadpole, pretty much, and away we go. I'm going to go autopilot again, and altitude hold again. So, pretty simple. We're now going to actually divert to waypoint 4. So let's press here, enter 0, 4, enter. And we're now going to basically cut our planned flight plan here. I'm going to disengage the autopilot this time, and manually fly around to waypoint 4. And then we're going to begin an approach and a landing back at Akrotiri. There we go. So you can see navigating in this aircraft is ridiculously simple. And as we're approaching Akrotiri, I'm going to put Tacan mode back on the HSD, so we get some symbology to help us align ourselves. And let's just leave this on autopilot just now, just to make our lives nice and simple. While I'm doing that, I'm going to actually set up my lights correctly for landing, because I just realised that I had taxi light on the whole time. I should have had the landing light on. So, that was bad of me. And apart from that, everything else is set up pretty much perfectly. We already have our Tacan pre-programmed. So, let's increase the speed a little bit. We can spare the fuel. Might actually be quite good to dump some fuel this way. Okay. And we're going to bring the throttle back now. Now, something else to note, we have different modes in which we can operate nav mode. We're currently in flight plan A. If we click here, we have the option to switch to flight plan B, switch to approach mode, switch to bingo mode, which will immediately give us guidance to our bingo airfield, or CRS puts us back into normal navigational mode if we've gone into approach or something like that. I'm not going to use any of those modes today. We're going to do a normal visual approach and landing, and in future videos I will demonstrate the approach system, which gives you an IFR capability in this aircraft. It's quite complex, but very, very capable. Oh, and actually, because we're at the end of our flight plan, it automatically put us into approach mode. Right, I actually don't want that, so I'm going to go approach, CRS, and that puts us back into normal navigation. So if you have auto mode selected, and the aircraft reaches the end of its flight plan, you automatically go into approach mode. It's actually just done it again. I'll get back into the vicinity of the airfield, and then I will manually toggle out of that mode again. And I think then it should start to behave itself. Actually, I could, of course, just put it back into manual. Press this, and we're back in fully manual navigation. So I'm going to get the speed down, and I'm going to get the altitude down, and we're going to conduct a normal landing. So once we get the speed below 300 knots, we're then able to lower the gear and also lower the flaps. We're going to use flaps for landing. You would use flaps for landing in all but the lightest of configurations. We're going to aim to fly our approach at about 180 knots, or at least the final part of the approach. We're going to use aero braking, so we want to basically maintain the nose pretty high. We want to put the bore sight cross on about the 10-degree line, even after touchdown. And then we're going to deploy the chute. There's a switch here to pop out the brake chute. And we also want to make sure our speed brakes are out at that point as well. The JF-17 has quite a long landing roll. It doesn't have amazing brakes. So you want to use aero braking, speed brakes, and the chute in most cases in order to land it within a kind of sensible distance. Otherwise you're going to land very long just using the wheel brakes. And we don't want to do that. You'll also notice that as I descend and come in towards the airfield, the aircraft is fairly slippery, even in this configuration where I've got the two big fuel bags. It doesn't really want to slow down too quickly. So I'm going to join downwind for runway 28 here at Akrotiri, and then we're going to demonstrate a touchdown. Speed in the pattern should be about 250 knots, and altitude should be about 1,000 feet AGL. So as we're getting to the right distance and altitude, I'm going to pop out my speed brakes, because we're still too fast. Let's get that speed under control. Okay, I can bring the speed brakes in now. I'm happier with my airspeed. Let's begin our turn onto downwind. Yeah, it really is quite slippery. It doesn't want to slow down too much. Okay, and that's about correct there for the downwind. Let's roll wings level. We're at about 250 knots. We're still high, so I'm going to let the altitude just come down slowly. Going to adjust the scale actually on my HS. Oh, there we go. Yeah, adjust the scale on the HSD so I've got better visibility of my position within the pattern. So at this point I'm going to configure, so gear down, flaps down, just wait for that to settle. You can see my increase in lift, I just balloon a little bit there. Want to throttle up a touch just to maintain airspeed. That's looking pretty good. Okay, without head tracking this is always a bit of a pain, so I'm going to turn my head over here and we can see that, yep, we're kind of beyond the touchdown point now. It's probably approaching 45 degrees, so I'm going to begin my turn. Going to let the aircraft descend as I come around as well. And make sure that I manage that speed. Yeah, speed's coming down nicely. And we're descending. So we want to put the flight path marker near the middle of the E bracket once we've got the aircraft settled on final. And we're at about the right speed and altitude just now as well, I think. Maybe a touch high, actually, so I'll throttle back a little. Actually, no. Altitude is now fine. Let's throttle up again. Yeah, actually, if anything, I've gone a bit low. And that beeping you can hear is high angle of attack. It's giving me a little warning. This is pretty hard to do without head tracking, but I think we'll manage. There's the runway. Okay, so we've gone through the center line. And we've gone a little bit low. But I think we can recover it. So let's get the speed under control, angle of attack under control. We want the flight path marker near the middle of the E bracket and positioned at the touchdown point. And we've kind of got it there already. That's actually looking not too bad. Yeah, that's looking good. So we're now just going to use the throttle to control our rate of descent. Get the aircraft nice and low before we begin our flare. We want to use as much of that runway as we can. Throttling back to idle. Touch down, keep the nose high. Air brakes fully out. You want to keep that cross at about the 10 degrees point. And now we're going to go deploy on the chute. We're going to nose forwards and start applying the brakes. And try to do so without putting steering input in. Below 70 knots, we're going to go nose wheel steering on. Continue braking. It's a little bit squirrely on the ground. Below 40 knots, we're going to drop that chute. Chute is jettisoned, and that is a standard landing. I'm just going to brake it to a stop on the runway here. And there we go. So you can see I actually used up most of that runway. And Akrotiri is not a particularly small runway. It's 9,000 feet approximately. So you can see that the JF-17, you have to be pretty careful about how you land it, and you're going to want to use that braking chute. Otherwise you're going to have a bad time of it. So that covers the basics of takeoff, navigation and landing, and the standard symbology and functionalities of the navigational systems. I hope that you all enjoyed that. If you haven't already, please subscribe, like and comment, and I'll see you all next time.